In this example, we'll be examining a scenario involving tulip colors. We'll enter data into Minitab Express in the form of a table. A company is selling tulip bulbs. They claim that they have an equal number of white, pink, and purple bulbs, and that when customers order them, they randomly select the bulbs from those that they have. You ordered 30 bulbs and received 16 white, 8 pink, and 6 purple. Is there evidence that the bulbs that you received were not randomly selected from a population with an equal proportion of white, pink, and purple bulbs? In this example, we're going to be conducting a chi-square goodness of fit test because we have 3 different groups, white, pink, and purple, and we want to know if there's evidence that the proportion of each are not equal in the population. So our null hypothesis is that the proportion of white equals the proportion of pink equals the proportion of purple. The alternative hypothesis then is that at least one population proportion is different. An assumption of a chi-square goodness of fit test is that all of the expected values need to be at least 5. Expected counts are equal to n times p. In other words, the total sample size, 30, times the hypothesized proportion of each group. In this particular case, n equals 30, and all of the hypothesized population proportions would equal 1 over 3, or 0.333. 1/3 times 30 equals 10, so all of our expected counts are 10. The assumption that all expected counts are at least 5 has been met, so we can go ahead to conduct our chi-square goodness of fit test. In Minitab Express, I'm going to make a table of summarized data. In one column, I'll put the colors. We have white, pink, and purple. In the next column, I'll have the counts. So for white, we observed 16, for pink, 8, and for purple, 6. Now we can use this summarized data to conduct our test. Under Statistics, I'll go to Tables, chi-square goodness of fit. We have summarized data. Our observed counts were in column 2, and our category names were in the color column. We're testing equal proportions. In the first table, for each of our 3 categories, Minitab Express will tell us the observed number, so this was the number that we entered in our table. The test proportion, so the population proportion that we're comparing our sample to. The expected count, so this is n times p. And then in the last column, the contribution to chi-square. So if we were doing this out by hand, this would be the contribution to the chi-square test statistic from that specific cell. Then Minitab Express will give us our chi-square test table. It tells us that we had a sample size of 30. Degrees of freedom are equal to the number of categories minus 1, so 3 minus 1 gives us 2 degrees of freedom. Our chi-square test statistic, 5.60, and our p-value. We can use this information now to walk through the 5-step hypothesis testing procedure. Step 1 is to write our hypotheses and check assumptions. We've already done this. We said that our null hypothesis was that P1 equals P2 equals P3, and our alternative hypothesis was that at least one population proportion is different. We checked the assumption that all expected counts were at least 5. All expected counts were 10, so this assumption was met. In step 2, we compute our test statistic. We did this using Minitab Express. For your lab assignments, make sure that you always include the output along with a little statement telling me what values you're taking off of this table. So in this case, chi-square with 2 degrees of freedom equals 5.60. Step 3 is to identify the p-value. From our Minitab Express output, we know that p equals 0.0608. Step 4, we make a decision. Because our p-value is greater than the standard alpha level of 0.05, we fail to reject the null hypothesis. And then in step 5, we state a real-world conclusion going back to our original research question. There is not evidence that your bulbs were not randomly selected from a population with equal proportions of white, pink, and purple. In other words, we do not have evidence to reject the null hypothesis, and we can't tell the company the bulbs that you sent me are not randomly selected because they could be randomly selected from a population with an equal proportion of white, pink, and purple.